Yes, welcome to the presentation to explain the mini project to our students who are taking MIS 231 Management Science course for the undergraduate program in BSBA Finance Department. In fact, this course belongs to Operations Research Department. Now I explain how to solve uh, an LP problem using LINDO. Uh, it's a very easy and simple process. As you can see on this desktop, the icon LINDO 6.1 Max XT. Double click this, and then since this is an evaluation version, we just press OK. And now you can type the problem which you have. Let's say, for example, we want to know the maximization case. Do not type Z there, right? Max 3x, for example, plus 5y. Now you press enter, then subject to some constraints. Let's say constraint number 1 is x plus y less than equal to, or you can simply say less than. The package understands that the constraint is in the form of less than equal to. So less than 25, enter. So you can put second constraint. Let's say we have a second constraint of say x plus 2y less than equal to say 100, and that's it. Let's say for this case we have only two constraints. So in order to know the constraints are only two, we need to tell to the package that these are all the things which are coming from our side as input. So this is on the untitled aspect. We are putting the problem as it is, right? Now you can press this icon, which means you can get the solution to the problem at hand. Okay, so now we press this, we get, now the package is asking us do range or sensitivity analysis. Now we click yes because we are interested in understanding the post optimality analysis, right? Apart from giving us this, you can see the LINDO solver status. It tells you that optimal solution has been reached by doing iteration, one iteration, right? And the objective is 125, okay? And the time it has taken is hardly less than 1 second, okay? So now let's press yes to get the final solution. So this solution you will not find on the uh, input slide. You have to just minimize this to finally get the output on the reports window. It says LP optimum found at step 1, objective function value is 125, this is the Z value, right? So it can be maximized. Variable which we have is X, we are not utilizing, so the reduced cost is 2, Y it's 25 value, right? So these are the dual prices already we have built. This is nothing but the shadow prices of the primal solution, right? Now coming to the sensitivity analysis, it gives you two kinds of sensitivity analysis. One is with the objective coefficient ranges, another is the right hand side ranges. Objective coefficient ranges, you can see that the current values or the current coefficients of the objective coefficients which we implanted was this. If you go to the window and go to the untitled, the current coefficients were 3x and 5y. So therefore we have here the current coefficients for x as 3, y as 5, the objective coefficient ranges. So you can increase, allowable increase for current coefficient for x variable is 2, and allowable decrease is you can decrease until infinity, right? So that means the allowable range is what we call it as 3 plus 2 5. That means I can increase my current coefficient up to 5 without changing the optimality of the solution. No doubt the z value will change. Similar is the case with current coefficient 5, right? I can change by reducing this to 2, right? Allowable decrease is 2, so that means 5 minus 2, so 3. E, after reducing by 2 units the coefficient of y variable, we can still keep the solution optimal, right? But as I said, the objective function coefficient value will change, right? Similar is the case with right hand side ranges, right? Right hand side ranges is nothing but, again you can go to the input slide, that is the untitled one. The right hand side ranges for the two constraints are: constraint 1 you have 25 and constraint 2 you have 100. So similarly the reports windows on the ranges in which the basis is unchanged is given as current RHS values. For constraint 2 is 25, constraint row 2 and row 3 is this. That means row 2 we have feeded the constraint 2, constraint 1, and row 3 we have feeded the constraint 2. So therefore the current RHS is 25, allowable increase is 25. That means I can increase further 25 without changing the optimality of the solution. Similarly, I can reduce till 25 without changing the things. Now coming to the current RHS value of row 3, which interprets as constraint number 2 in our LP equation, right? So now the allowable increase is infinity. That means I can increase to any point of value without changing the objective function, right? Similarly, if I go for decreasing, I can change by reducing to 50 units. So therefore the range of optimality is 50 to infinity. That means the current RHS value of 100 can be reduced to 50 and increase to infinity. So the range of optimality, which will not change the optimal solution, is until that point. Okay, I think you understand this. So now we give an assignment to you, the mini project. I think every one of you are aware of this mini project example which I have distributed in the class. So same exercise we have done. Now we are followed with certain questions, right? I think I can show you this. This is the example mini project we had, right? You were given a paragraph which gives you an idea of the LP problem, that is the inputs of the LP problem. You need to formulate the model, then put this model in your LINDO package, get the solution, and do the interpretation for the following questions. So I want your page 1 as the formulation of the model. As I explained in the class, the 4 steps. So you need to follow these 4 steps. Okay, now going to the solving the LINDO computer package, it's very simple. You just do this in the LINDO package, copy it and make a printout using a Microsoft Word document. Once you do this, this becomes your second page of your mini project. Okay, then the third and final page is nothing but the interpretation of the following questions from C to H. Okay, C to H. These are the following questions you are going to interpret on page 3. So in total, including the cover page, your mini project should contain minimum 4 pages. Page 1 about your name, university ID, right, and the course name and the mini project title. That is the title page. Second page should contain the model formulation. The third page is the printout of your LINDO computer package, right? And the fourth page is the interpretation of the following questions. So that's what I'm looking for. So the entire mini project will give you 10 points. So all the best. And the deadline for submission is uh, 2 weeks, right? Or I can put it until June 5. Okay, so the deadline for mini project is June 5. If you have any further questions, you can take an appointment with me anytime. You can walk in the office hours. I'm available on a one-to-one basis. If you come in groups, that will be fine, because it is, I can take a special class also. Okay, so all the best in your project. Thanks.